The video that follows explains clearly how to cure the intermittent shutting down of the Athlet, the Bosch Athlet range of vacuums. The problem is the connector joining the handle to the main body and the motor of the vacuum. What I've done is remove the connector and in their place soldered in a length of wire about 8 inches long. That allows the handle to be removed, and so that you can actually perform the soldering. There are 4 wires each end of the connector, so 8 solder joints, lengths of wire, and this has cured the problem totally. So there is no shutting down of the vacuum cleaner when in operation. It doesn't occur. It's 100% fix. The thing that surprised me was that now the vacuum has a longer battery life. Now that surprised me, but it certainly runs for a longer period of time. So I hope the video helps you, but it's far better than contact cleaning the existing contacts. That is really not the most efficient way to cure this problem. Once you've soldered these wires in, you're back to normal. What I've also done is I've been experimenting and just using up to power 2. Now I've just taped it at the moment. There is no turbo power kicking in, so I'm just running it at 2, and I've just put the banding on so that the handle and the body, I don't forget that the wire is in situ and pull them apart and then break any of the wires. So that is a handy thing. Or the other way, just to cover the catch which is on the back. So I hope this video helps you. It's 100% cure. It's worth doing. Well, I've returned again to my ongoing project, which is the Bosch Athlet and the intermittent stopping while I'm vacuuming. Just stops. Now, to cure the stopping, you switch off the vacuum, you reconnect it to the charger, give it a couple of seconds, disconnect the charger, and you're ready to go again. My intermittent fault is, I think, caused by the connector. It's this, which is situated in the bottom of the handle. And what I've done is I've soldered with wire rather than use the connector. Now I have cleaned the connector and that improved matters considerably, but I am getting an intermittent. This intermittent fault is when it's onto turbo. So I'm not sure if it was a fault in the connector, which, as you see, I've cut. I'll just show you at the side. You're going to need a T20 with the tamper-proof hole, and there are 6, 2, 4. Start again. 2, 4, 6 screws here, which you'll need to disconnect. There is no need to drill any holes because you're removing the connector from the top of the vacuum unit, and that will leave a rectangular space hole where this once fitted. Now I've taken that off. I've left about 1 centimetre there just in case everything goes wrong and I need to resolder it back together. There are just 4 wires to solder, and they will then feed through the handle and rejoin, and I've used the existing connector here to resolder. What you will need to do is to, once the wires are connected, is to move that up into the next void, because if you just leave it in situ, it's going to interrupt. It will then pressurize the wires which are going through the holes, so they have to be separate. There needs to be a void so that the wires are not crushed. Just know on the handle, these are, the wire is, the loom is connected to the switch and it serpentines through slots so that the wire doesn't interrupt the top. The cover itself needs to be a small prise the cover off. So once you remove the 3 screws of the cover, prise one corner up and then it will run all the way up and the cover itself can be removed. The body, I didn't need to separate the body from the cover. I just used a wooden wedge and the connector can then be lifted and brought to one side so you can solder outside the body of the vacuum cleaner. Contact cleaning does improve things immensely on the switch, but there are, where the two join, there is definite signs of erosion. The nickel covering, the chrome silver covering definitely has been worn away, and beneath on this shows copper, but I believe on here is brass. That can cause oxidation. It's not the best of conductivity. The best solution, I think, is to solder this. The wire that I've used is burglar alarm wire. As used in a burglar alarm, it's quite fine, but don't use anything too high a gauge. It's going to be difficult, but if you are pressed, you can use lighting flex. Probably 1mm lighting flex would actually do, a length of that. The length that I've used and checked, 220mm. So you're going to need 4 strands, probably about 1mm, but you can go lower. And there we are, and it all works. This, I think, is the problem that has been encountering many people. I'm sure it's this point, and that can lead perhaps to other problems, I don't know. Just a point to recognise, the battery is live, so when you're soldering this, just remember that we have a live wire amongst this, which is called the ground, and that is live. So the red wire is live. Cut each wire from the body that is coming out from here, which is connected to the battery. Cut each wire individually so that you don't cross circuit any of them. So work on one wire, solder it, insulate it, go to the next. Just remember you're working with a live wire because the battery is connected.